Let A and B be n by n matrices with entries from a field F. And let C be the product AB. We claim that if A and B are both invertible, then C is also invertible. In fact, C inverse is given by B inverse times A inverse. To see that this is indeed the inverse of C, let us call it D. And we'll show that D times C and C times D are both the identity matrix. So D times C is B inverse times A inverse times A times B, and A inverse times A is the identity matrix. And the identity matrix times B is again B. And here we have B inverse times B, and so this is the n by n identity matrix. Similarly, C times D is given by A times B inverse times A inverse, and B times B inverse is the identity matrix. And here, the identity matrix times A inverse is again A inverse, and A times A inverse is the n by n identity matrix. So by definition, D is the inverse of C. More generally, if we have n by n matrices A1 up to AK all invertible, then the inverse of the product A1 up to AK is given by the inverse of AK times all the way down to the inverse of A2 times the inverse of A1. So let's look at an example. Suppose that this is my matrix A. So it's the product of three matrices. In fact, all these matrices are elementary matrices. Now, if you multiply them out, you'll see that A is equal to 1, 3, 1, 2. So, to form A inverse, we just reverse the order of these matrices and take their inverses. So, we have 1, 3, 0, 1 inverse times 1, 0 minus 1, 1 inverse times 1, 0, 0 minus 1 inverse. But as mentioned before, these are elementary matrices, so forming the inverses is quite easy. So the inverse of this matrix will be 1 minus 3, 0, 1 times the inverse of this matrix is 1, 0, 1, 1. And finally, the inverse of this matrix is 1, 0, 0 minus 1. And if you choose to multiply this out, you'll get A inverse equals minus 2, 3, 1 minus 1. Finally, we look at a fact that we won't prove here. So suppose that C is the product of A and B, where A and B are n by n matrices with entries from a field F. Now, we are not making any assumptions about the invertibility of A and B. But if we know that C is invertible, we can conclude that both A and B are invertible. This fact is not trivial to prove without some further machinery. But once we have discussed determinants, this result can be shown to be true.